Here's an epic story of the British Empire, that vast tapestry forever being weaved by the unceasing efforts of her citizens. Just as the memorable flight of Scott and Black in 1934 annihilated the distance between England and Australia, so does the great industrial venture we are going to unfold reveal the nearness of the mother country to her dominions. Halfway round the world from London is Perth, capital city of Western Australia, standing on the shores of the beautiful Swan River. Today it is a thriving modern city with a population of more than 200,000. Western Australia covers an area of nearly 1 million square miles, almost 10 times the size of the British Isles. The importance of the capital of this vast territory is obvious. Less than 70 years ago, Perth was merely a small rural outpost of the empire, and the almost magical transformation of the tiny village into a modern metropolis, a romance in itself, symbolizes the initiative, ambition and vision of our imperial citizens. By 1935, Perth's ever-increasing demand for electricity had taxed to its limit the capacity of the existing power station, laid down in 1916, and it was decided to build a great modern station, equipped with a new power plant of the latest design. As a result, Mr. William H. Taylor, the general manager, invited tenders for the construction of a complete power station incorporating high-pressure generating plant, the boilers of which were to burn local collie coal in pulverized form. A contract of this nature is of the greatest imperial significance, for it results in the forging of yet further powerful links between the old country and the new, both working side by side on the construction of this huge plant. To London, heart of the empire, comes Mr. W. H. Taylor to discuss plans with the successful contractors. At the head offices of International Combustion Limited, the many departments commence their preliminary work, every man playing a part in ensuring smooth coordination during the fulfillment of the large and comprehensive contract. At the London offices of the Agent General for Western Australia is signed the contract for Perth's new pulverized fuel-fired boiler plant. The first signature to be appended is that of Sir Hal Colbatch, CMG, the Agent General, followed by Mr. George C. Usher, Managing Director of International Combustion Limited, the principal contractors. Thus, plans are set in motion involving work for thousands of men in all branches of industry, both at home and in Australia. Immediately, the myriad wheels of great undertaking begin to revolve. Skilled technicians discuss the final designs. The drawing office at Derby starts on the plans, after which detailed drawings and specifications are issued to the various works. Meanwhile, having seen launched the great project to provide Perth with abundant power and light, Mr. Taylor leaves London to return to Perth, satisfied that his ambitious development is in the right hands. From the air, we introduce you to the 55-acre plant at Derby, the pulse of the project, where much of the plant will be manufactured and from where all the contributing contractors both in Britain and Australia will be directed. By careful engineering organization, Western Australia and England become one, the progress in each country being co-related and controlled from a single source. In Perth, the ground is being cleared and foundations laid for the vast building and the massive equipment it is to contain, the work being executed in accordance with plans from Derby. Thus, the capital city's dream of modern power gradually approaches reality. The construction of the building is entrusted by International Combustion to the Structural Engineering Company of Western Australia, a constant contact being maintained across 10,000 miles by letter, by cable and by telephone, just as if it were only across the road. By now, operations are well in hand at Derby. Patents have been made for much of the equipment, as for example the huge Lepolco pulverizing mills, which will be required for the conversion of coal into powdered fuel. In the foundry, the cupola is charged with correctly determined proportions of carefully selected materials. The completed mill pattern is taken to the foundry to be incorporated into a mold for casting from molten metal. The mills are a vital factor in obtaining high efficiency, as each produces 10 tons of finely ground coal per hour, as fine as flour. In due course, the molten metal is tapped into a ladle and poured into the huge mold from high above the foundry floor. In the laboratory, a staff is continuously at work, making careful tests of all the materials employed. The manufacture of the boiler combustion equipment involves repetition castings for economizer tube fins, stoker parts and other equipment. These castings are made on this interesting continuous conveyor, a most modern moulding plant having a capacity of over 22 tons per shift of 8 hours. Among the many widespread and varied industrial activities, which are all concentrating on one focal point, Perth's new power station, is the huge Sheffield works of English Steel Corporation, where the forged steel boiler drums are being made to the order and designs of international combustion. Here we find one of the few power presses in the world capable of forging the steel drums to withstand the high pressures required with modern boilers. From an overhead crane, we view the great machine shop in which lie the steel boiler drums, like massive guns asleep. One by one they're machined, an operation that is a triumph of precision work. Now over to Derby to inspect the progress being made. Rough castings have arrived in the machine shop, including the Lepolco mill we saw being cast. The body weighs 13.5 tons and the base 7.5 tons. Again, the miracle of modern precision engineering is exemplified, as the large mill is machined to the exact dimensions prescribed. In another shop, the senior economizer is fabricated, the heated fin sleeves being shrunk on the coal-drawn steel tubes. As its name implies, the economizer is designed to economize by transferring what would otherwise be wasted heat in the gases to the boiler feed water. What the paper pattern is to dressmaking, the template is to accurate modern steel plate construction. Here is part of the Derby template shop. The plate shop provides an impressive sight, as the massive machines cut through the tough steel like butter and bend it as easily as a double-jointed acrobat bends his back. Here too are the familiar processes of welding and riveting, so widely used in the construction of boiler and furnace equipment. Now we're in far-off Newcastle, New South Wales, thousands of miles away from Perth, on the other side of Australia, where 600 tons of steel for the power station's framework are being fabricated. The Broken Hill Proprietary Company's plant being one of the finest in the world, supplying Australia with much of her iron and steel requirements. Flowing like milk, the molten metal is poured from the furnace straight into molds, where it cools and becomes solid. A striking example of how a heavy industry is controlled with remarkable ease and swiftness. Again, the ingots are heated, and then, white hot, are passed through rolling mills. Each time they pass under the rollers, their thickness is reduced, and their length increased, until they are shaped into the required plates, girders, and rails. Meanwhile, proof of the progress made at the Derby works is offered by the many and varied parts of machines which have been fabricated, as seen in the erecting shop. The Lopelco mill, which we have glimpsed in various stages of manufacture, is assembled into one solid machine, a job demanding a maximum amount of skill. Note the neatness with which the parts are assembled without fuss, and remember the great weights which are being manipulated. Assembling an Apolto exhauster, which removes the ground products from the mill. The combustion chambers of the modern water tube boilers are often entirely surrounded by finned tubes, which you now see being made. The fins are welded to the sides of the tubes, so that when they're assembled in the furnace, it becomes almost completely steel-clad and water-cooled. The finished tubes are bent to the required shapes. As with every other component part, great or small, they are carefully checked and gauged. The Iver soot blower keeps the boiler tubes clean, ensuring efficient steam generation. The powerful movements of a Goliath crane introduce us to the Derby stockyard, where the equipment of every kind is loaded for dispatch to all parts of the world. The first chapter in this story ends with the completion of the manufacturing work in England, and the next begins with the great task of transporting the component parts. From Derby, the power station equipment for Perth starts on the first stage of its long journey, carrying potential power from Britain to Australia. London docks bring us to the edge of the seven seas, for centuries the main highway of empire. Every ship, however humble, journeying to our dominions and colonies, weaves yet another thread into the imperial fabric. Here equipment is being transferred to a vessel that will carry it to distant Australia, thus fulfilling the contract so generously given by Western Australia to the mother country, and thereby helping her heavy industries. However, London is but one of the ports from which completed. The great steel boiler drums are being dispatched by rail from Sheffield to Liverpool. And though the morning is misty for their arrival at the Liverpool docks, the future outlook is bright. Each boiler drum weighs 20 tons, and its walls are 4 inches thick. Despite their great weight, they are loaded with comparative ease into the good ship Trojan Star. This undertaking has entailed the shipping of 3,000 tons of iron and steel, and more than 6 miles of water and steam tubes. And so, in addition to having employed all kinds of craftsmen, work has been given to a multitude of transport workers on land and sea. Anchors aweigh! The Trojan Star heads for the sunshine. The climate of Western Australia is one of the most temperate in the world, and it is a typical sunny morning when the cargo of boiler drums reaches Fremantle. Thus the imperial network is strengthened, threads of commerce intertwining, knitting the distant dominions into a perfect unity. The huge drums are unloaded and transferred to the railway. As Perth is but 12 miles away, they have practically reached their journey's end. But can this be their destination? When last we were here it was bare. Indeed, an example of determined work and of accurate timing for the delivery of the machinery from the mother country. Concreting is well underway. Supplies of cement coming from the nearby works of the Swan Portland Cement Company Limited, who, strange as it may seem, make cement from oyster shells, which are dredged from the riverbed. The shells are then transported in barges to the plant, where they are ground to powder and converted into one of the finest cements made. Whence come all these shells with which the riverbed is covered, no one knows. Volcanic upheaval is suspected. We are not going to try and compute the number of shells that abruptly left their bed to help complete this great work, but it must be quite a few, judging by the amount of concrete that's being used on the job. The plant begins to take shape. The huge drums are hoisted into position, 60 feet above the ground. Here under our eyes is being created the largest power station in Western Australia. High-pressure steam produced in the water tube boilers by the combustion of pulverized coal furnishes power for the steam turbines, which in turn drive the huge electric generators. There are 3 steam generating units, each producing 135,000 pounds of steam an hour at a temperature of 820 degrees Fahrenheit and a pressure of 625 pounds to the square inch. Tubes in which water becomes steam are expanded internally into the holes in the drums under such pressure that a steam-tight joint is formed. Here is a closer view of the boiler, partly tubed, and showing the finned tubes forming the furnace walls, which were last seen being constructed 13,000 miles away in the shops at Derby. Now the economizers are being assembled. Their casings and the air heaters are being fitted into place. We are looking along what will be the exhauster floor. When the powdered coal is removed from the mill by the exhauster fan, it is so fine that it can pass through a screen with 40,000 openings to the square inch. Then it goes to burners in front of the furnace. The burning pulverized coal converts the water into steam 4 times the temperature of boiling water. Those flat circular discs in the casings cover the pulverized fuel burners. Here is the refractory lining being applied round the burner nozzles. The installation of the turbo alternator. Its condenser transforms 250,000 pounds of steam per hour into hot water, which is collected and taken back to the boiler feed tanks. The assembly of the Parsons turbo alternator, capable of developing 33,000 horsepower, representing an output of electricity sufficient to light 500,000 50-watt lamps. The output of the station is controlled by switchgear supplied by Metropolitan Vickers. When planning a modern boiler plant, the utmost care needs to be taken to utilize every available inch of floor and roof space to the best advantage. On the boiler house roof are the fans supplying the air for combustion and for drawing the gases from the boiler. On the way to the chimney, the entrained dust, which normally would be discharged into the atmosphere and befoul it, is removed by a remarkable apparatus with the even more remarkable name of the electrostatic dust precipitator. The steel chimney, 20 feet in diameter, will ultimately be 183 feet in height. The building rapidly nears completion, and it will be seen that a utilitarian structure need not offend the eye, nor disfigure the landscape. As our friends are breaking off for lunch, let's journey 100 miles south of Perth, where lies the bush township of Collie, from whose coal mines will come the coal for the power station. The combustion of all this coal produces large quantities of ash, and this problem is efficiently dealt with in this modern plant, the ashes being carried by water to a concrete bunker. In the bunker, the waterborne ash is separated from the water. Now arrives the great day when the power station is complete, and perhaps we may fittingly quote Kipling. Some water, coal and oil is all we ask, and 1/1000th of an inch to give us play. And now if you will set us to our task, we will serve you 24 hours a day. Now Mr. Taylor, who has studied and directed every process in the gradual completion of this great enterprise, has the enviable task, together with the company's resident engineer, of surveying the finished plant, the last word in steam and electrical generation. Immaculate control panels have superseded heavy levers. Boilers are mechanically fired, and the whole of this enormous, sensitive plant is controlled in the modern manner with a minimum of physical effort, resulting in maximum efficiency. And so the story draws towards a conclusion, but it has no real ending, for the history of imperial enterprise is unceasing. The torch of progress is carried further into the future. The light it gives forth is symbolized by electricity, and despite the 10,000 miles between the old and the new countries, its rays will shine upon Great Britain. That so great an undertaking should be completed with such smooth efficiency is a tribute both to the engineers responsible and to the vision of those controlling the destiny of Australia. Australia's engineering manpower has apparently enjoyed the experience of working in close conjunction with the men of Britain. The completed station, as you see, is quite attractive architecturally. The black smoke pouring from the chimneys of the old station is a fitting farewell to the days when smoke was synonymous with the combustion of coal. It is characteristic of the progress of the empire that this mighty structure has been designed to give light to the citizens of Western Australia in a world of dark clouds. Illumination, both material and spiritual, is forever growing stronger by the combined efforts of Great Britain and her dominions.